Okay. So with that being said, hi everyone. My name is Eric, and I'm joined with by Dr. Is it Dr. Andrei Vokolov, or are we still working? I think you're. So we're joined by Andrei, who is co-running the DPID working group with me. So here to talk about that a little bit today for a couple reasons. So for starters, want to give some background and some context on the work that the DeSci Foundation is doing around the open source backend of DeSci nodes and the general persistent identifier technology, in addition to why it's important. So the first point is context. The second point is ways to get involved. As this is an open source group, we're growing relatively fast and have some interesting points where people can actually come in and help out. I see Logan on the call as well, who actually just came into the working group a few days ago and had some wonderful thoughts around grants and some of the work that can be done getting funding to fund open source technology. And then finally, the last thing is just a point of open discussion around where folks would like to see this go, what role the DeSci Foundation plays in, what things could be helpful as next steps. So with that being said, I'll go ahead and get us kicked off with just a quick history. So in Sci DataCon 2023, which was a conference hosted as a part of the International Data Week by the Research Data Alliance, Andre posted a thread in one of the larger chats around the concept of decentralized persistent identifiers. And he spent the better part of the entire week kind of pounding the halls, talking to people about the idea that we can use IPFS as a more decentralized and verifiable means of persistent identification. Unbeknownst to Andre, DeSci Labs had been working on this topic for a little bit, and he had also been working on this topic for a little bit. So after that conference, the two of us met up and decided to continue working on dPIDs in a more collective and collaborative manner. So over the course of a couple different calls, which are all openly posted on YouTube, and I'll point you to them throughout the course of this conversation, we're able to come to a mutual understanding of how IPFS and associated decentralized technologies really can be used to build better, scalable, more autonomous, incredibly neutral, persistent identifier infrastructure. So I think it's been going on for the better part of 2 months now and has seen a lot of progress. So from essentially myself, Andre, and maybe two or three other folks at the start, the Google Groups now has closing in on 50 individual members. The Mattermost has about 15 active contributors. We've been able to push out, I think, 2 conference proposals with another 2 or 3 on the way, have written the beginnings of 1 grant and have started to identify quite a few others, and just have been getting a lot of engagement and activity as a whole. So one of the first documents that was written was something called the prospectus, which was a recommendation by one of the group members named Francis, who is actually relatively influential in the working group itself. And actually, big news before I go too far into that, for anyone who's curious to learn more, you can find any and all of the links that you need at the newly pushed dPID website, which has a second subpage entitled Working Group. So if you scroll a little bit down, you'll see things like read the overview, join the team. So I'm going to go ahead and start sharing my screen, and we can go through some of those links together. Please let me know whenever y'all can see it.
Yeah, we can see it.
Awesome. Thank you. So yeah, what we're looking at here is the dPID working group page. And I think the most important aspect here is as you scroll down, you see different potential ways to get involved. We put a fair amount of time at the beginning of the working group stand-up into writing a prospectus, a quick 2-page document on why this technology matters, what it can do for the world, what the working group's goals are in an initial short-term approach, what longer-term visions can look like, and what artifacts and deliverables we can expect to come out of this. Now, with the understanding that this working group was formed at an event centered around the FAIR principles, this one-pager is, I think, to a certain extent, focused on the FAIR principles themselves. With the understanding that some of the ideas presented within can be expanded into other points. Actually, as I'm doing this, I'll go ahead and put the links to this into chat as well for draft. So the main gist of this prospectus, the why DPID pager, I think the main reason that kind of came from discussion amongst different individuals as to why decentralized persistent identifiers matter is the idea that a machine readable and machine actionable scientific record, as is being pushed by the FAIR principles and as is needed by publishing enterprise, means every single file needs a persistent identifier. And that can be a huge challenge. So I was working with a researcher a few months ago out of Columbia University who essentially was handed the keys to the supercomputer. Through a series of grants and some clever maneuvering, he was able to secure about 22 million core hours on the Stampede 2 supercomputer. And over the course of a month, he, as an assistant professor, and one of his grad students made about 750 terabytes of data. What they ended up making was a cubic centimeter scale simulation of wind turbulence across the island of Manhattan, which is really cool and amazing. We worked with them to store 14 of the 750 terabytes that were there. That created somewhere in the neighborhood of 700,000 individual files, this 14 terabytes, which means 700,000 persistent identifiers. Then beyond that, whenever they went to publish this, they created 7 different version histories to show the growth of this research object. So we have 700,000 files to start with, times about 50, because we only stored 2% of the data, times 7 for 7 version histories. And then if we're really sticking by the rule book of FAIR, every file needs an accompanying metadata file. So that's times 2. In a machine readable and machine actionable scientific record, that one research project with one assistant professor and one grad student who had the keys to the supercomputer would have made 500 million persistent identifiers. That's a lot. Ultimately, the challenge of machine actionability on the scientific record and one of the impossible questions underpinning the FAIR principles is how do we scale to that number? What does scalable persistence look like, and how is scalable persistence possible? So with that being said, this prospectus gives a very brief outline of that problem, and then talks about the fact that persistence is not just an issue for academia itself. Everyone on the internet has experienced a 404 error at some point in time. And as such, open source communities have started building. So it then goes into a very brief overview of the technologies which are used to ensure persistence. And I think this needs to be updated based on some feedback from Chris, but essentially it's IPFS and IPLD, blockchain, and alongside side tree and decentralized identifiers. It gives a brief overview of exactly how those technologies combine into a functional persistent identifier system. And that is the one pager on why. That is essentially the gist. It's because you give one assistant professor the keys to the supercomputer and they can make more files than we have DOIs in existence. So going beyond that, as we look at the working group itself, as this is a more functional document, the next section in this prospectus details the short to medium term things that the working group would like to achieve. So we have the why, we have the problem, we have the vision. Now we jump a little further into the what. And essentially, the working group is aiming to do three individual things. Number one, build a simple, successful proof of concept, something which is essentially just spinning up an IPFS node at 3 to 5 individual universities, which can show that if each group stores or pins 1 terabyte of information, no individual group stores the entire piece of information, then all of a sudden we can start working towards data publishing in a more sovereign manner, where custom APIs connecting individual institutions aren't needed, where the verifiability of content address storage and the distributed nature of P2P networks can work to stop vendor lock-in, link-in, and link rot, and content drift. So this simple POC is the very first thing that we're trying for as a working group. Then beyond that, next thing we're going for is a series of coordinated proposal submissions. Every time we get into a call as a working group, we got some brilliant people in there, and it's a lot of fun, but everybody throws out a new idea of something that needs to be done, some problem that needs to be solved, some question that needs to be answered. And I think our answer to this as a working group has been, yes, you're right, that does need to be solved. Let's start thinking how to get funding for that. Let's start thinking how to coordinate proposals on a higher level so that they tie in together. Let's think about what an order of operations for building out this open source software looks like. And that is the intention of this coordinated proposal submission as the second point. Then third is the beginnings of a community of practice. So this starts as a working group, a couple passionate people building on a technology that they think is important for the world, for the future of humanity, quite frankly. But eventually, this probably turns into something that's a little more governance, managerial, that is as much about knowledge management, architectural capacity, and advising as it is about actively building in and of itself. More so, this coordination layer is intended to be something that's worked towards in a more scaling phase. So it's not something we start with, but having, I guess, support and a repository of information to pull from is a very important part of, quite frankly, good ops, good operations is an important thing for trying to bring others on board. So those are the 3 points after we go through why dPID. It's get a single success story and publicize it to no end, coordinate some proposal submissions on what the next steps can be, and then start forming a community of practice with the intention of building artifacts to scale. Then objectives beyond that, deliverables, I think kind of mirror a lot of what's already been said in all of this. So I won't spend the time going into it, but this is kind of the heart and soul of the dPID working. Now, I'm not going to take a pause just yet. We're going to go back to this main website and take a look at a couple other things. So for starters, the opportunity to join the team. So for anyone who's actually curious, there is a fairly lengthy thread of conversations around decentralized persistent identifiers, which has been going on in the larger Mattermost channel for quite some time. With a public forum that stretches for a good while, we tend to keep things fragmented into threads. Information on conference submission that we're trying to do. So for instance, this is a conference that Andre wrote to about the use of decentralized persistent identifiers in automation and manufacturing controls. This is a new proposal that we're likely going to be writing around Persistent Identifier Fest in Prague. It's a conference all about PIDs that should actually be a good time. I think Marshall's writing one for the Center of Open Science as we speak, and the list goes on. But it's been a lot of fun. We've had some decent success, actually. The first ever proposal that we wrote for the Fair Digital Object Forum was actually accepted, which is a great thing to see. So Chris will be presenting on that in March. Whole lot of different names, but if you're interested to come join, we encourage you to do so. If you want to join the Google group, that's this Get the Highlights tab. You can see the open source code. browse the codex documentation. And then finally, the knowledge management repository is done in Google Drives. So we have a good bit of information around dissemination, kind of overview documents, meetings and discussions, grants funding, case studies, all that. So we would encourage you to come in and read this, and more importantly, to come in and help build this, as spreading the word not only around some of the challenges that a fair scientific record can face, but additionally about what we can do to help. So that's kind of the gist. And with that being said, I'll go ahead and take a pause and pass it over to Andre to see if he has anything which he thinks I missed, which he thinks is important, which he would like to add. Any thoughts or comments, Andre?
Yes, thank you very much. And well, what I wanted to add that just today I was studying the problematics of automated control in the context of dPID, and as well, sorry was that I don't have a presentation, but I could say that the one of the most important problems we have in the industrial environment is persistent logging. And in the logs, we can actually to mint a PID for every record. And this record could be produced in millions per day for some facilities. Even I can estimate for the place so in which I am working in, Letra Synchrotron, and it's around 150 controllers, and every controller produces some log records every minute, for example. So it's around an addition to your explanation about the let's say the need in the new kind of PID. And yeah, sorry.
Oh no, I was going to say this pops up everywhere. I mean, it has been a constant point talking to Eric Schultes about the Human Immunome Project. I think he's estimating he's going to make 1 trillion persistent or 1 trillion individual files every single year just on his own, not even as a function of the entirety of the Human Immunome Project. And we see examples of this from just about every domain of research.
Yeah, and the second point I wanted to add is that I already have. Let me please share my screen now to show some document. It's about the case studies. Can you see it?
Yeah, we can see it.
Yeah. So I have a discussion with a very enthusiastic professional gallerist and one of my friends who is a painter. So they are actually told me about the absence of a system that can persistently identify and try to make provenance for the artworks, both digital and the artworks, especially that have a hybrid distribution in hard copy and digital copying. So we have now actually developed an data model. And this data model was discussed with again with a professional gallerist who is really interested. And so there is a document in the case studies folder in our Google Drive. So anyone can participate in discussion about the data model and, which is more important, with the access models and the trust model of the system that can base on dPID and that can identify and persistently and make provenance for the artworks. And this is already let's say the side branch of our work in our working group, on which someone is already trying to find support and funding for this kind of proposal. We already have an exact scope and the vision of the trust model, so we can try to have a web of trust in such a, let's say, the difficult environment as artistic is. So yeah, for now, please have a look, just a brief look.
Well, and to me,
Yeah.
what's really important to this is the idea that this persistent identifier technology goes past just research, that it really can be used by a wide field of domain
Yes.
accordingly.
Yeah, and also I could add that the let's say the primal request, I had received it a lot of time from a lot of people asking them about the persistent identification. All of them were asking me about the prefix model. So because if you, for example, if someone wants to mint their own persistent identifiers, most of these people just want to have a prefix and the possibility to define and prove this prefix using the private key. So probably it will be the primal request for our working group when we will prepare our proof of concept and demonstrator project.
Yeah, and this is primarily folks within academia who have requested this.
Exactly, exactly. And here is a model of trust. It's an English translation I made over the Italian translation made by my friend. So this we can consider these points as the exact requirements to the infrastructure that could be considered trusted in the artistic society.
It
About
looks
the
like,
sorry?
oh, no, I was just saying, it looks like Leonie dropped in a question if this is like open to share with someone who she knows who's worked in the art gallery or art identity app space.
Sorry, sorry, I didn't hear too loud. So can you repeat,
Oh,
please?
sorry. Yeah, I was just saying Leonie was asking if this is open to share.
Yes, yes. Literally, it's open to share.
And I just pasted the link in chat for anyone who's curious.
Thank you very much. Yeah, so probably after the Eric's talk, I have nothing anymore to add. Despite that, we are having now, let's say, we are searching now for the funding for the grants, and we are now in the stage of defining a scope for the existing grant proposals available in the most academic societies, and also in photon and neutron societies and robotic society in which I am working in. So the dissemination is already started, I could say, and well, we are going and we are seeing how will it go.
And I think it's solid. And one of the most important things is trying to get dissemination outside of just the open science infrastructure community. So I love seeing work coming in around the use of this for art, around the use of it for mechatronics. Probably more work to do around other fields which do have larger data and provenance needs. To me, one of the opportunities that was most interesting that's actually been on my list to get back in touch with was a woman who makes persistent identifier infrastructure accessible to those in Africa. So one of her biggest points, and I think she's gotten the chance to speak to UNESCO and others about this, is given currency fluctuations, the cost of minting DOIs for research is incredibly expensive, and large portions of data collection for specific fields of science happen exclusively on the African continent. But people take that data, bring it back to whatever university they're working in, more than likely in the Western world. And once they have it, it's kind of gone. So the idea of provenance on that data is a huge part of why she's working for PIT infrastructure. And I would love to bring that forward as a possible point of discussion. Two interesting possible use cases for this come from AI on both sides of the coin. So those making AI models can actually use quite a bit, can actually use the provenance aspect of dPID in helping to showcase their work. And I've started to hear that more regularly. But what's actually been interesting to me is a point that started to come up more recently around publishing infrastructure and the idea that, you know, a lot of publishers are starting to deal with AI spam, where it's papers coming in from paper mills that have been accelerated thanks to tools like ChatGPT. And it can be very hard to distinguish these. So having infrastructure to showcase provenance over a period of time where a human being has reliably gone and continuously updated a research project as opposed to just writing a manuscript and throwing it out there could be another very interesting use case. But I'd be interested to open this up to the team. So we've got mechatronics, we've got AI models, we've got stopping AI spam, we've got artwork. What other potential use cases do you think would be interesting things to pursue?
Well, the next probably will be let's say, the legacy provenance, especially for the software, because we have now some initiatives like the software legacy identifying, but I don't think they would be, let's say, successful over the existing platforms like GitHub, because they actually don't store the lateral artifacts. They are storing the code.
So are we talking about like software heritage?
Sorry?
Legacy software, what specific organizations do you mean?
Well, software heritage at first and web archive.
Yeah. Yeah.
Yeah, because we have in our watch list on also the conference dedicated to web archival proposals, and probably we will be wanting to disseminate over the society. I think it will be a good use case for us.
I think that would be fantastic. And we do have a couple archivists in the working group right now. I think that's actually Marshall's primary field is data archival.
Yeah, and also for in terms of heritage, it would be really useful to preserve some, let's say, the rarely you can find it rarely in the internet, but they are digitized and stored somewhere, some old books. And for this, we know, yes, we know that something like the project we are doing right now is already used, but we cannot rely on them, mostly by the copyright reasons.
Yeah.
So that's again the use case to share both the books and let's say the provenance of licensing or these books.
It would be amazing to be able to share, especially anything that does not have or that has licenses which are more on the permissible side.
Yeah.
Pull out whatever we can. Yeah, no, I think that would be fantastic.
And also the possible use case I see is the sharing the data or the environments which are not completely networked. So if we have some station which is remote and which is far away from some, let's say, the cellular networks and wired networks, we can use the possibilities of IPFS to share the data of these networks.
Are you saying like the chunking aspect of IPFS?
Yes, yes, and also the aspect on which you can identify the data and to deliver the PID or the physical channel. Then to have an opportunity, yeah, and then having an opportunistic approach to retrieve the data.
That would be very interesting. I've seen quite a bit coming from the most recent Davos forum about protocol labs handling data storage on the International Space Station for this exact reason.
Yeah, but my first point of view here is an oceanographic. If
Okay.
Yeah, if because if we have something like the robotic submarine working deep in the depths of the ocean, it can just rise away and after that retrieve the data, mint the PID, go with the data sharing, and afterwards just proceed after it will just recharge the batteries, something like that. It's really yes, really easy
Oh, that's a
explanation.
cool idea. Yeah. No, that would be fantastic. That would be a wonderful use case.
Thank you.
So does anyone else on the call have thoughts around kind of, because one of the points that we've gotten from members of the working group is try to find some of these unique ideas which showcase the true benefits of this system outside of what can be done in the normal system. So can anyone else think of ideas where kind of the dPID and decentralized networks, where dPID and the decentralized networks technologies, dear Lord, underpinning it can work to shine?
Well,
I added a
sorry.
comment in the chat there. I'm not sure if it could be used for that purpose at all.
AI art models, Nightshade. Could decentralized artwork identification be used to help prove cases of art theft that circumvent Nightshade?
Logan, can you maybe give us a little bit of background what Nightshade is? I'm not familiar with that.
I don't know all of its technical aspects, but simply it's some sort of software or service. I'm not entirely sure about the details. That makes it so if a AI art model steals somebody's artwork to incorporate into that model, it corrupts the model in a way that it makes it generate bad artwork.
Oh, cool.
Yeah, I don't really have a technical understanding of it.
Okay, I was wondering what circumvented Nightshade? Like, are there, because you mentioned that sometimes Nightshade didn't work. Do you have an understanding of why it doesn't work or no?
So, I mean, there's cases where somebody just hasn't applied Nightshade, obviously, but there could also always be the case that somebody makes a script that instead of just downloading artwork directly, it takes a screenshot of it, and then that would, I think, circumvent it. Again, I'm not sure about the technical aspects of it, but I'm sure if there's a will, there's a way, of course.
Well, I can just to suppose that in the Nightshade service there is some noise generator, which actually mangles the convolutive part of the neural network analyzer. And yeah, but yeah, you're right. It's pretty easy to circumvent it using the screenshots. But the thing here is we should, I think here we should concentrate on the binary identicity of the files. And this is why when we were exploring the artwork use case, this professional gallerist, my friend, told me that it will be the best that only the author and the agent can, let's say, authorize some sizes and some formats of the digital artwork for being distributed. So we can rely only the content ID inside IPFS. And probably for me now, I don't see any other ways to circumvent the tools like AI spam and Nightshade hacking scripts.
I just wanted to say that I find these ideas around applying dPIDs to the artwork, to the art world, absolutely fascinating. So I totally love this, and I also really like your idea, Andre, about Oceano. Well, you know what? Exactly that. Yes, but this is great. This is really cool. Fantastic ideas.
I'm wondering also related to the kind of the oceanography. I know there's been some talk about creating creating tokens that are defined by certain resources. For example, oil or a certain like local resource like fish or something like this. Would identifiers also be a potential assist here where it's like, all right, we have in order to create this token and have it actually be based in the resource instead of this being defined by this kind of loose connection between what somebody's thinking, is there a way to create identifiers for more physical objects, or is that translation actually a lot messier?
Well, it's interesting to think about, I guess, more the tailored perspectives of what dPID can and can't do. So one of the more interesting use cases that's been brought up as a part of the dPID working group is the idea of tracking conceptual drift by assigning DIDs, not dPIDs, but DIDs, to individual concepts in controlled vocabularies, and then using dPIDs as the tree to connect information, similar to what you would have in a taxonomy. So that as information gets shifted around as a part of a larger knowledge graph, you can actually start using artificial intelligence to map some of that conceptual drift and mirror it in dPID version histories and structures. And I'm trying to get one of the members of the working group to actually come in and talk about some of the work that he's done on decentralized identifiers for controlled vocabularies and how that maps back to this larger dPID tree structure framework. So I don't know if it necessarily is the right case for physical, although I think it's going to be a very interesting use case from the art world. It could be something that we could see, but I can definitely see more of a concept of identity and ownership coming out of any of these given tools.
Cool, thanks, yeah.
It's really cool how much progress you guys made in such a short time with the working group. It's really nice. So how many people are actually actively engaged in the working group? I know that we have like what 40 people or so who are like lurking around in chats, including me. Never doing anything.
Well, from 8 to 12.
I would say so. And I would say it's myself and Andre who are really leading the charge, with maybe 2 or 3 folks who are involved on either a daily or a weekly basis, and about a dozen who can be called in at any given time based on the need. That would be kind of what I would say. So for example, with the FDO forum conference proposal, I think there was one tenured professor, I don't know if she's technically a professor, from Brookhaven National Labs, Dr. Line Pouchard, who was instrumental in kind of helping us create that document. Another member from the Synchrotrone was a key part in kind of writing that, Yorgos. And then Eric Schultes also came in with some wonderful commentary. So for that one document, I think we had like 8 individual authors, which ended up coming in handy whenever we had to scramble for a presenter. But there's actually been a fair bit of traction, and we've recruited some other folks along the way. So Slava from Don's has been in there on a more or less a daily basis. Same with Marshall from Pennsylvania. So there's some good traction, and it's continuing to grow as word spreads.
That's wonderful. Really, really cool.
Yeah. So does anybody else have thoughts or questions around all of this?
I had a question I wanted to ask, which was related to what you were saying initially. When you were discussing about the scale of these dPIDs. So I just wanted to dig into a little bit more the mechanism behind that, like what makes a dPID so much more scalable? And once we have all of these dPIDs, like what do we do with them, right?
Sure. So what makes a dPID significantly more scalable is the fact that we can use technical primitives to ensure large swaths of persistence as opposed to relying on social contracts. So I'm actually going to send a link to the final open draft, which should hopefully actually be going out soon, to a blog post for the Research Data Alliance forum, I suppose. So I'll quickly share my screen as we're looking at this. This particular blog post actually goes into describing some of the challenges of scaling the existing system. And in essence, the answer is it's a problem with architecture. So whenever you look at existing PID systems, they tend to be either centralized or pseudo-federated. And honestly, this centralization can be a very positive thing. If you look at a persistent identifier system like ORCID, where we're probably not going to have trillions of individual scientists who need to be identified, there's a very good chance that what will actually end up happening is 10 to 15 million. This can be handled by a trusted third party, by a trusted organization. And that's what they do. And with a lot of the money that they have, they provide auxiliary services. So ORCID is typically used for single sign-on in a lot of academic tooling. And that has been a huge part of how it's actually gained adoption. ROR is a similar fit-to-purpose centralized architecture for a relatively small volume of information. And DOIs, if we think about DOIs as a persistent identifier for manuscripts, they're also fit to purpose. Given that essentially you have one large nonprofit sitting at the top and a series of registrars down below who all control their own operations and are responsible for their own persistent identifiers. The problem comes whenever you start to think about some of the network effects around the fact that for the actual DOI schema itself, there isn't necessarily a good way to verify the information. It makes things like database migrations very difficult. And that responsibility then becomes fragmented across the series of registrars who have minted the PIDs in the first place. And Andre actually has done quite a bit of work looking into all of this, but I think that would be a good example. And I actually wrote another piece for the Next Generation Internet Grant around some of the other persistent identifier systems which are out there. So for example, ARC and Pearls from the Internet Archives. And they do tend to take a more centralized approach, but their problem tends to be more operational expenditure. So it's capital. It's a question of, can I get enough money to make sure that these identifiers continue to resolve and that the system continues to work? And that's a difficult challenge in and of itself. So to me, the scalability, first off, it comes from the fact that we're using content hashes as globally unique, persistent, and resolvable identifiers, which is inherently easier and simpler, making it more scalable. It comes from a decentralized architecture, which takes some of the risks of the system going down and spreads them across a wider network. And then it comes from more efficient, from this decentralized architecture, kind of helping to lead us away from some of the capital expenditure and from some of the operational expenditure traps that existing PID systems have run into. So that would be my point, but I would love to open that up to Andre to kind of maybe detail a little bit more of the centralized and federated aspects, as I think you've spent a good bit of time looking into this.
Yeah, because I spent a lot of time in the Expanse project of European Union to explore the federated aspects of DOI and handle architectures. So here we have, let's say, because the federated architecture is a compromise between the scalability and reliability for the PID system. And this is how, at first, the handle system is built. So in the federated architectures, however, we have the aspects that limits the scalability because we have a lot of different registrars. And once we have a lot of registrars and every registrar should support its own registry, then it could be the situation when the registry is not available for all the network. And sometimes it happens. For example, if some research institution can be out of a network, the federated system should find a backup. But this backup is the creation of this backup is up to the administration of the current federated architecture. And here we have another problem on which I'm always explaining it in our documents we are creating. It's the problem that the algorithm and the exact provenance schema of most of the already presented persistent identification systems is closed. So once the customer, let's name him customer, cannot recreate the persistent identifier on its side and to see if it is, let's say, mathematically provable or not, and he doesn't have any proof, then we have the problem of a social aspect, social contract, or a persistent identification system, that the provider of the persistent identifier has is the only provenance holder for the identifier itself. So it's let's say it's important problem, and it's also has a huge influence of the aspect of data sharing. Because when we are sharing the data, we want to see the integrity of the data, and then it is possible to publish hash CRC. But who will prove that this CRC is minted over the exact data set, and it was not, let's say, it has the same provenance chain that the original data has? This is a question. And in IPFS, we have, let's say, the natural way to resolve this. Eric, please, can you add something?
Yeah, absolutely. And I think that verifiability is a huge aspect whenever we start thinking about the scales of information that are there. If we're talking about 10 million identifiers, I mean, even that is something that you do start to need this verifiability for. But if you can imagine trying to do a database migration with 10 trillion individual line items and no good way to check whether or not your database has migrated properly, that is, in fact, a recipe for disaster. So this is another piece that we wrote as a part of the working group. There's been a lot of writing that's come from this. It's been fun. And I'll share my screen again, which uses a framework that Eric Schultes brought back from the National Academies to detail more granularly how we can think about persistence and persistent identifier systems. So it splits the idea of persistence up into 6 different key points. The persistence of the payload as a thing, with the payload being whatever the identifier itself is pointing to. So for instance, the data, the metadata, whatever is resolved to. The persistence of the mechanism to handle the payload's non-persistence. So we understand that data just inherently cannot be persistent in most instances. If we have a gigabyte data file and a drive gets corrupted, well, there's not a whole lot you can do to make sure that that data is going to be around. Bit rot is a thing. But any persistent identifier system needs to have a mechanism to handle that data's non-persistence, to say it's no longer around and that's a part of life, but here is a tombstone. That data did exist at some point. It was stored at this location or with this hash, and if it ever comes back, this is what you should be looking for. Then you've got the persistence of the identifier as a thing. So literally just the string used to resolve to any given piece of information. The persistence of the binding between the identifier and the payload. So as you think about any given lookup table, you're going to have two columns where it is the identifier and the thing that said identifier is resolving to. We have to think about the persistence of that table to make sure that the mappings stay around. The persistence of the service to allow for resolution between the identifier and the payload. Once you have that lookup table, okay, great. Now, how do you get from the identifier to the payload? And then finally, the persistence of the service to allow for the updating of that resolution, or the persistence to allow for the updating of the binding between the identifier and the payload. And as we think about all 6 of these points, at least to the best of what I've been able to come up with, this is a more complete mapping of what persistence would actually look like from a functional and capability-based perspective. So in this particular post, I outline the centralized, decentralized, and federated points of where the dPID system lies on each of these. I didn't go into it, but in existing systems, a lot of what we have is a series of social contracts or human-to-human agreements in ensuring the persistence of any of these pieces of information. So by working to automate persistence on a more granular level, we can actually work towards a more efficient and scalable system. So that would be another piece of writing that I would point you to in answering this question.
Thank you.
Yeah. Does anyone else have questions?
I was wondering if you could elaborate on the dPIDs for the controlled vocabulary stuff that you talked about.
I am not going to, but I will send you a paper that details this particular paper was pre-dPID. So I think it more focuses on decentralized identifiers themselves and less on the ability to track content and semantic drift. But I can show you that information, and I'm working on getting the person who originally wrote this paper to actually come and speak at one of these forums, as I think there will be some really interesting discussion. So here is the link to that paper, and you can read on your own.
Thank you very much. Yeah, it sounds absolutely fascinating.
Yeah, it's good stuff. Slava's a smart guy. So he was trying to do this in Dataverse, but ran into quite a bit of hesitation in Dataverse around the use of decentralized identifiers. Anybody else? We got time for one last question.
Well, we have 3 minutes, and yeah, I just wanted to ask to send to me the recording of this webinar, so I can run an AI model to subtitle it and then share everything.
Yeah, we will send that as soon as it comes off of the digital printing press.
Okay, thank you.
And for anyone, I guess, just to close this out, for anyone who's interested in helping with this, the one thing that we need right now is people to help identify and write both conference proposals and grant proposals. Helping to spread and disseminate the word around this open source backend is the best possible thing that we can do right now, both as a means of financing travel for the folks who are spreading the word, continuing to support ongoing development for some of the more open source community oriented aspects of dPID, and helping to bring on different use cases for the technology itself. So if you're interested in helping, Andre and I have a complete list of grants and conference proposals that are on our plate right now, and we've made good progress, but there's a lot more to do. And with that, I think we're probably at time for today. So just wanted to say thank you, Ellie, for having us, and thank you to everyone for listening.
Thank you very much, and also thanks to you for the talk. It was really awesome.
Thanks, guys. Really great.
All
Really,
righty.
Thank you.
everything's developing really fast.
Yeah, it's moving. It's a good time. It's a good time.